specific episode, we are going to talk about the metals and non-metals, the difference between metals and non-metals, and we are going to talk about the transition metals, those metals located here in this section. They are called transition elements or transition metals. Yes, we are going to start to define the metals, the non-metals, and after that we are going to continue with the classification of the materials in two big brains, in organic materials and inorganic materials. Those metals here, located over there, are transition metals, very important metals for our program, for our career, transition metals. And the metal located here, aluminum, germanium, all of those are metals. If you see the division is here. There are three elements located in the limit, in the edge of the division. Those elements are carbon, silica, and germanium. Carbon, silica, and germanium. Those three elements, they are in the limit in between metals and non-metals. For that reason, those three elements are considered semiconductors. Those three elements are located in the group number 4. Those elements produce excellent structure, because the people ask about why the carbon fiber and the fiberglass, the structure is strong. Let me demonstrate why. Suppose that we have a carbon fiber. We have the structure of the mat of carbon fiber. That heavy structure is basically carbon, atoms of carbon together. Let me check what happened in that structure. I have carbons, I have carbons, I have carbons, pure carbons. And let me verify how many electrons have a carbon in the last orbit. 4 electrons, no? According with the periodic table, it's located in the group number 4, is 4 electrons. What happened if I put more carbons and more carbons and more carbons and more carbons? Yes, all of them, they have 4 electrons in the last orbit, and they can create covalent reactions in between one and the other one. They share electrons. At the end of the day, each atom complete 8 electrons in the last orbit. 1, 2, 3, 4, 5, 6, 7, 8. And the structure is a perfect structure. It's strong, because it's not possible introduce additional elements, because the structure is perfect. The bond of the system is perfect. Each atom complete 8 electrons in the last orbit, because share other 4 electrons with other 4 carbons around the structure. This is a perfect structure. Now we are going to analyze the elements located in this period. They are called transition metals, transition elements. The majority of those elements located in this group, in between this point and this point, in between scandium and copper, they work in the last orbit with 3 electrons. And only this small group, zinc, cadmium, and mercury, they work in the last orbit with 2 electrons. This is very, 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 very important, because right now we are going to understand why elements like zinc are used to protect other metals against corrosion. Suppose that you are driving your motorcycle in the morning, 6 a.m., 7 a.m. in the expressway. It's easy at 6 a.m. in the first of all in the most important expressway of your country, is easy move in your bicycle at 7 a.m.? Probably no, because the traffic is heavy and the concentration, the amount of cars in the expressway is full. It's difficult. It's difficult move it. That expressway is practically full of cars. When the expressway is completely blocked, it's because the expressway have 8 electrons in the last orbit. It's full. It's not possible move it. For that reason, those elements located in that group, they are considered noble gases, noble elements, because they don't react. They are full. They are relaxed. The element located in the group number A, they have the last orbit full. The maximum is A, you remember? A is full. The element located in the group number 7, they are practically full. They only need one additional electron. You think that those elements are good conductors of electricity? You can move your motorcycle easy with 95% of the cars in the expressway? No. No. For that reason, the elements located here are considered non-conductors, non-metals. Non-metals. You remember the division? Non-metals. The non-metals in the groups 6, 7, 8 are bad conductors, non-conductors. This is the zinc, and this is the oxygen. The oxygen with the 6 electrons in the last orbit. And the zinc with 2 electrons in the last orbit. Once again, what element have more energy? Oxygen is located in that corner, and zinc less energy. Okay, in that case the zinc release the electrons. The zinc release the electrons over there, and the oxygen complete A, and the zinc 0, and the molecule is this. That molecule is too simple. In other words, for the oxygen, it's better when the oxygen find a piece of zinc because attack directly. The oxygen don't need call other 3 guys and other. No. It's not complicated. It's simple. Attack the oxygen. Yes, my friends. For that reason, you can put a piece of zinc over the copper or over the iron, over the aluminum, and the oxygen attack the zinc and not attack the aluminum.